Did you know that nearly 78% of modern engines that fail catastrophically before 100,000 miles show clear signs of oil degradation long before their official service interval? Dealerships and manufacturers often claim that oil changes can safely be spaced 10,000 to 15,000 miles apart. But the reality is far more alarming. Laboratory testing of 326 vehicles and inspections of 115 engines with premature failures revealed that by just 5,000 miles, engine oil can lose over 57% of its critical protective properties, well before the dealer suggests replacing it. While skipping or delaying oil changes may seem cost-effective today, the hidden costs in repairs, often averaging $4,200 per major engine repair, can quickly outweigh any perceived savings. This transcript dives deep into the science, evidence, and expert advice on what really happens inside your engine, the risks of extended oil change intervals, and what you should do to protect your vehicle. Number 1. Evolution of oil change intervals. Marketing versus reality. Historically, oil change intervals have shifted dramatically. 1960s, 1970s. Standard recommendation was every 3,000 miles for virtually all vehicles in America. 1990s. Many manufacturers extended intervals to 5,000 miles. Today, recommendations often range from 10,000 to 15,000 miles, depending on the vehicle and region. At first glance, it may seem that modern synthetic oils have improved drastically, justifying these extended intervals. While synthetic oils do offer better temperature stability, oxidation resistance, and performance under extreme conditions, the improvements are incremental, not revolutionary. Independent testing confirms that vehicles adhering to 10,000-mile intervals show significant oil degradation by 7,500 miles, according to James Martinson, a former product development engineer at a major oil company. The chemistry of motor oil has improved, but not nearly enough to justify doubling or tripling oil change intervals. These decisions are largely driven by marketing, not engineering. This discrepancy is amplified by the fact that recommended intervals assume ideal driving conditions, continuous highway driving in moderate climates, which represent less than 15% of real-world driving patterns. Number 2. What happens inside your engine? Between oil changes understanding. Oil degradation requires examining the internal wear and chemical changes that occur over time. 0 to 3,000 miles. Oil darkens from combustion byproducts, but additives remain fully effective. Minimal engine wear is observed. Viscosity levels remain optimal. 3,000 to 5,000 miles. Detergent additives begin to deplete. Small carbon deposits form on valve trains and piston rings. 5,000 to 7,500 miles. Anti-wear additives are significantly depleted, particularly in turbocharged engines. Viscosity modifiers begin breaking down, reducing temperature stability. Sludge formation starts in oil galleries and timing components. 7,500 to 10,000 miles. Oxidation accelerates. Deposits increase on critical components, and where metals like iron, aluminum, and copper rise by roughly 58% compared to 5,000 miles. Beyond 10,000 miles, sludge buildup restricts oil flow. Bearings wear rapidly due to reduced oil film strength. Turbocharged engines are especially vulnerable, with oil temperatures exceeding 300 degrees Celsius. Michael Davidson, an engine teardown specialist with 28 years of experience, states, "The difference between engines maintained at 5,000 miles versus 10,000 miles is dramatic. Especially in turbo engines, extended intervals can result in accelerated wear that's unmistakable." Number 3. 5 critical ways. Oil degrades. Engine oil is a complex fluid performing multiple critical functions, and failure in any one function can lead to expensive engine damage. The 5 primary ways oil degrades are: oxidation. Oil molecules react with oxygen, forming acids and sludge. By 7,500 miles in urban driving, oxidation reaches significant levels. Additive depletion. Up to 25% of motor oil consists of additives like detergents, dispersants, anti-wear compounds, friction modifiers, and corrosion inhibitors. By 7,500 miles, 50–65% of protective additives like ZDDP can be depleted. Viscosity breakdown. Shear forces thin the oil. Laboratory tests indicate that by 8,000 miles, many synthetics lose 20–30% of viscosity, falling outside rated specifications. Contamination. Fuel dilution, water, and debris reduce oil protection. Short trips often lead to 5–8% fuel dilution by 7,500 miles, drastically impacting lubrication. Base oil degradation. Thermal cracking and hydrolysis irreversibly break down the base oil molecules, especially under turbocharged engines' extreme temperatures. Dr. Thomas Reynolds, a tribologist specializing in lubricant analysis, explains, oil degradation accelerates over time. Oil at 10,000 miles often experiences 3 to 4 times the wear of oil at 5,000 miles due to compounding effects. Number 4. Why modern engines are more sensitive to oil. Quality contrary to popular belief. Modern engines require more attention to oil quality, not less. Several factors increase sensitivity. Tighter tolerances. Modern engines often operate with clearances as low as 0.001–0.002 inches, compared to 0.030–0.04 inches in older designs. Higher operating temperatures. Coolant temperatures now often exceed 210–220 degrees, accelerating oil breakdown. Turbocharging. Turbochargers can exceed 1,800 degrees and spin at up to 300,000 RPM, placing extreme stress on oil. Variable valve timing, VVT. These systems rely on clean, pressurized oil to function. Sludge or deposits can lead to failures exceeding $1,200 per repair. Robert Johnson, an automotive design engineer, notes, as engines have become more sophisticated, the tolerance for degraded oil has decreased, yet marketing pushes for longer intervals. From an engineering perspective, this is backwards. Number 5. The alarming effects of extended oil change. Intervals fleet studies reveal a troubling pattern when vehicles follow 10,000+ mile intervals. A 5-year fleet study of 436 identical vehicles, half on 5,000-mile, half on 10,000-mile intervals, using synthetic oil showed that by 60,000 miles, 81% more excessive engine noise, 62% more oil consumption issues, 41% more check engine lights, 27% more catalytic converter replacements by 100,000 miles. The extended interval group had 137% more major engine repairs and reduced resale value by 4.7%. Turbocharged engines suffered even more, with failures occurring 2.88x more often at 10,000-mile intervals. Average turbocharger replacement costs exceed $2,000, amplifying financial impact. Number: normal versus severe service conditions. Most manufacturers' extended intervals apply only under normal conditions. Severe service, what most Americans actually experience, includes short trips, 10 miles, stop-and-go traffic, extreme temperatures, 35 or 90 dusty environments, towing or hauling, prolonged idling transportation. Studies show that over 75% of drivers encounter at least 2 severe conditions regularly. James Wilson, a service advisor with 22 years' experience, says 8 out of 10 customers qualify for severe service. Yet the sales process rarely emphasizes this. Extended intervals are primarily a marketing tool to make vehicles appear lower cost to own. Number 7. What oil analysis labs? Reveal Independent Oil Analysis provides unbiased insights into real-world oil performance. Conventional oil, 3,500 miles, 47%, shows significant oxidation, additive loss. 5,000 miles, 72% fail viscosity spec, 7,500 miles. 91% fail at least one spec. Synthetic oil, 5,000 miles, 38%, show oxidation, additive loss. 7,500 miles, 64%, show wear metals 10,000 miles. 83% fail at least one specification. Dr. Sarah Jenkins, a chemist specializing in lubricants, explains, even the best synthetic oils degrade significantly by 7,500 miles. By 10,000 miles, most samples no longer meet API standards, with iron, aluminum, and copper levels indicating ongoing engine wear. Number 8. What mechanics do with their own vehicles? A survey of 104 professional mechanics revealed 0% follow 10,000-plus mile manufacturer intervals, 14% change at 7,500 miles, 67% change at 5,000 miles, 19% change at 3,000, 4,000 miles. Master technician Robert Martinez says, the difference in engine condition between 5,000 and 10,000 mile intervals is dramatic. I would never risk extended intervals on my own car. Number 9. The financial reality. Cost analysis. Comparing $5,000 versus 10,000 mile intervals over 150,000 miles. Scenario A. 10,000 mile interval. Oil changes. 15 fates $85. Yon $275 expected repair cost. $999. 37% probability of $2,700 repairs. Resale impact. $750 total life cycle cost. 3,024 scenario. B. 5,000 mile interval. Oil changes. $85. $2,150 expected repair cost. $297. 11% probability. Resale impact. $0 total life cycle cost. $2,847. Despite more frequent oil changes, the 5,000-mile interval is more economical over the vehicle's life. Elizabeth Warren, financial analyst and automotive consultant, emphasizes that consumers often overlook the repair probability and resale value, which significantly impact total ownership cost. Number 10. Recommended evidence-based oil change intervals based on lab analysis, fleet data, and expert opinions. Oil type condition. Interval conventional SEV RE. City, short trips, extreme temps. 1,000, 4,000 mi conventional normal. Mixed driving, moderate climate. $1,000 mi synthetic. Severe, $5,000 mi synthetic. Normal 7,500 matters may turbocharged all conditions. Reduced by 1,000, 1,500 neoanarid diesel WI. DPF is severe, follow severe service guidelines vehicles. 100,000 dollars me all reduce by $1,000 me Dr. Robert Thompson, mechanical engineer specializing in lubricant technology, summarizes, optimal oil change intervals occur between 5,000 to 7,500 miles for most modern engines. Beyond this, degradation accelerates while cost savings from extended intervals vanish. Number 11. Dealer-performed oil changes. Caveat studies and investigative reports reveal issues in some dealership quick service centers. Use of lower-grade oil than advertised, incomplete draining of old oil-rushed procedures, mischecked fluids, improper torque on drain plugs, reuse of gaskets that should be replaced. James Rodriguez, who worked at 3 dealerships over 12 years, explains, oil changes are often loss leaders. They're assigned to inexperienced technicians under time pressure. Not all dealerships are problematic, but it highlights the importance of a trusted service provider. Number 12. Practical steps for vehicle owners. Check your manual for severe versus normal service. Most urban drivers fall under severe. Set oil change intervals based on evidence, not the manufacturer's maximum. Document oil changes carefully for warranty protection. Consider oil analysis at 5,000 miles to understand your engine's condition. Monitor turbocharged engines closely. Verify used vehicle's oil change history. It matters more than mileage. Manufacturers balance engineering with marketing. Owners should prioritize engine longevity and reliability. Following these guidelines protects your engine, saves money on repairs, and extends vehicle life. Understanding the science behind oil degradation empowers you to make smarter maintenance decisions. Share your oil change habits in the comments and consider subscribing for next week's discussion on fuel additives dealerships don't want you to know about.